Hello everyone. So today I'd like to show how to create a Hello World application on Vivado and Vite software. The hardware platform is Cora board, which use the Xilinx ZYNQ FPGA. Okay, so we follow the procedures here. Let's say, and here let's say, because the video can be long, let's say I just provide 3 videos. The first one is to create a XSA project, which is from Vivado. Okay, let's start. So create a project, new. Yeah. Okay. Select directory. Okay, just put this name. Tick this one. At your project. So we don't add this kind of thing. We have a board. I already added the Cora board configuration here, so I can directly select the Cora board here. If you haven't added this one, you just select the FPGA ID for the Cora-Z7 board. So this one, Cora-Z7. No, we are using this one. Cora-Z7 and 07. Yes, this one. So you can check, actually the ID is this one. Let me double confirm. XC7Z007 SCLG 400. Okay. Okay, then we say we follow the procedure here, right? We follow the procedure. So right now we go to the step 3. So create this one. Let's say we just use default name. You can change the name. We have a so-called canvas. So it's the place so we can play. For this Hello World project, we don't write any Verilog code or VHDL code. So for this Hello World, we just instantiate the CPU. So we know for the ZYNQ, inside we have a processor system and the programmable logic system. So for this one, we don't use the programmable logic. Okay, right? This one. Add this one. So okay, then we click this one, right? We just click. Then we have this. Then we'll connect the FCLK. Let's say you once place your cursor around this this terminal, the cursor shape will be changed like a pen. Okay. Then you validate. Validate is this button. Validate the design. some timing error. So here at this moment we ignore because we don't use DDR memory. Save. Then we click generate block design. This kind of parameter doesn't matter. Okay, then we click this source, click this one. This is your block design. We right click, create HDR wrapper. So you can select this one, copies generated wrapper to allow user to edit. Let's say in future you can edit the Verilog file. Okay, so you see this one will be changed, this hierarchy will be changed. So right now the design topic is the block design. So later we will have you see we have a Verilog code to describe this block design. So this one actually is a Verilog code. Then after that, because for this one we just have the processing system. We don't have any programming logic. But for this one, let's say we are going to generate the bit stream. But before that, so we need add the constraint file. So let me copy the files here. Let's see, I have some design files. So let me copy it here. Let's say hello. Let me copy here. Let's say this is the directory. This directory, this file has been uploaded to Moodle system. So later we will use a constraint file from here. So in this one, I want to add or create constraints. Next, add files. You see here. So this one is this directory we just copied here, right? XDC. We go to XDC. The constraints. So we just use the default constraint because actually for this hello world we don't use any IO pin, but we still need to specify that. You can have a look. It defines the clock or something like that, right? Then we need just generate the bit stream. Before generating bit stream, I recommend that you guys can run the synthesis at first to see if there's any issue or not. Let's say if run synthesis is fine, then later we just click the generate bit stream. Because the procedure to generate the bit stream is long, if there's some error in the generate bit stream, this procedure, it would waste your time. So in engineering, it's better to know problem early. So run synthesis is a quick way to know if there is any problem in your design or in your setup or not. Because as you know, for this Hello World project, we don't write any code. We don't write any Verilog code and C code. But this one, Hello World is used to test your environment. Okay, then we need to wait for a while to see the synthesis result. So right now you can see here at the top right, it's running, right? Running synthesis. Okay, then for us, we don't do this. Actually, we can run the implementation, but we want to do one more step further, we directly generate the bit stream. Okay, yes. So this procedure, let's say on my computer, would take about 10 minutes. You can have a cup of coffee and then come back later. Okay, this one is relatively fast. So it's done. Let's see, I'll click cancel. Then what should we do? We follow the procedure here. So right now, we already did here, and we already generated bit stream, right? Then we need to do this export hardware. So according to figure 10, so here. So file, export hardware. Please click this one. Click this generate bit stream. Then we'll download. No, not download. Generate the XSA file. Need to wait for a while. So let's have a look at the directory. So this is hello XSA. This is our project name. Later the .xsa file will be generated here. Oh, okay, you see here generated, right? So that's all for the first step.